This video will explore the basics of building cross-sections in Petrel for log analysis, well correlation, and to analyze the stratigraphy and structure of your project area. Cross-sections can be built using a number of methods, the most common of which is picking the wells on a 2D or 3D window. Now, generally it's much easier to pick wells on a 2D window because the 3D window renders objects with perspective, and it can sometimes be harder to pinpoint the well you want. To create cross-sections, select the cross-section editing tool palette located in the stratigraphy pane. The first icon to the left contains functions to add hinge points to a cross-section, either by selecting a well path, well symbol, well top, or by clicking on any XY location. When you activate this button, a callout will appear to the right-hand side of the tool palette. Select the starburst to create a new cross-section, or begin picking to edit the one already located in the selection box. When you press the starburst, Petrel will create a well section window and associate it with the new cross-section. The well section window is used for the bulk of your well correlation and well log displays. It will also ask for a well section template. Well section templates control which data to display in the well section window and the style controls on those data. I will cover well section templates in a future video, but for now I will select a general triple combo template and press OK. The well section window will appear as a tab at the top of the active window viewport. With the cross-section added, it's time to add some wells. Notice the cursor turns into crosshairs when hovering around a well symbol and changes to a hand elsewhere. If you press your left mouse button in hand mode, Petrel will add an XY location as a hinge to the cross-section. If you select a well using the crosshairs, it will use the well itself as a hinge point. I will now create a cross-section down the axis of the anticline. When you are finished editing the cross-section, simply put yourself back into another mouse mode, like View or Select. Now let's say you missed a well at the beginning of the cross-section. If you want to add one in, you can hold down the Shift key to add a hinge to the beginning of the cross-section. And if you want to add a well in between existing hinge points in the cross-section, you can select the second button in the tool palette, then left-click and hold the cross-section segment and drag to the well you wish to add. To delete a hinge, select the third button in the tool palette and select the hinge you wish to delete. Cross-sections in Petrel can be used to project structure, seismic, and 3D model properties, among other things, into a plane for viewing in an intersection window or even in the 3D window. So let's consider a situation where you have an object which you would like to precisely position the cross-section through. In this example, a polygon characterizing the crest of the anticline, but this can be done with seismic inlines, crosslines, 2D lines, polyline intersections, composite lines, and intersection planes, among other objects. This can be done while in Add Hinge mode by holding down the Control key and clicking on the planar object. Then run the cursor down the object to trace out the interval and click again to finish projecting across the object. Petrel 2022 and later versions contain a novel cross-section creation tool called the corridor cross-section. With corridor cross-sections, you digitize a simple polyline and define a buffer region within a given distance of the polyline. It will then grab all wells within the buffer zone and build out a cross-section. What makes this tool truly powerful, though, is the ability to build in a step increment and rebuild the cross-section with the wells inside the altered buffer zone. This ends up allowing you to reposition your cross-sections on the fly, much like you can with seismic data. To build a corridor cross-section, first select the corridor cross-section button in the tool palette. This is the fourth icon from the left. Once selected, a callout appears with parameters for buffer zone and to move the corridor. First, digitize a polyline by using your left mouse button. While you can place any number of points in the line, keep in mind that the simpler, the better. Once you have created the line, you can adjust the corridor width with the slider bar. If you need it larger than the slider extends, you can type a number in the box to reflect the range. Once you have the plane and buffer region set as desired, select the green checkbox on the lower right-hand side of the callout. This will create a cross-section from the corridor as well as a new well section window. Once you press the green checkbox, the auto update option becomes available. Toggle this on to refresh the cross-section whenever you alter the corridor. You can also use the callout to further refine the corridor by rotating, setting the moving direction, and setting the moving step. The swap section is a specialized single well cross-section feature that allows you to quickly swap a single well out of a cross-section with another. This allows you to check and correct data quality issues such as data busts and well tops. To use this tool, select Swap Well in Single Well Cross Section in the tool palette. This is going to be the third button from the right. Then, select a well you would like to view. Petrel will again generate a new well section window. Set this template and name if desired and press OK. I usually like to tile the well section to the left side of the display. From here, you may QC and edit well tops. When you are done, go back to your 2D window and select a new well. The swap section will drop the previous well and pull in the new well for QC. Cross sections have a plethora of style settings. These can be found by double-clicking the cross-section located in the cross-sections folder within the input pane. Style settings are specific to the active window, so the cross-section can have different appearances in different windows. The Style tab contains settings to control the color, line thickness, and appearance, hinge point shapes, and labeling. For now, I will thicken the line width, make the labels a little bit larger, and locate the labels to the start and the end of the cross-section. The Definition tab allows you to control the order of the hinge points within the cross-section. You can do this interactively to disable windows and hinge points from view in the cross-section, without altogether deleting them. It also contains settings for the well's display within the well section window, as well as how the well is projected into the plane for deviated display. We will explore these features when we cover the well section window in another video. The Alignment subtab allows you to change the hinge points of the cross-section relative to a position along the well's deviation survey. Petrel defaults to snapping the hinge to the toe of the well, but can be moved to the wellhead, the middle of the survey, or even to a specific well top. To recap, in this video we explored the basics of creating and editing cross-sections in Petrel, as well as how to add planar objects to a cross-section. We looked at the Corridor cross-section tool, which allows you to pan through wells interactively, much like 3D seismic planes. We looked at the Single Well Swap section, which allows you to quickly QC and fix data busts in your well tops one at a time. Finally, we looked at some of the common style settings you will use to change the appearance of your cross-sections. Thank you for watching. If you found this video useful, please share with your colleagues, or if you have any feedback or something you'd like to see in the future, just leave a comment below.